Good afternoon. Today we are working on PO4. I can find the greatest common factor of a set of numbers. How many of us remember factors from last year? Few of us. As we go through it, you're going to start saying, oh yeah, that's what it is. So a factor is a number that goes evenly into the given number. And of course it doesn't want me to write up the page there, so let me write it here. So a factor is a number that goes evenly into the given number. So you're given a number, they say, what are the factors? You have to look at what are the numbers that we multiply together to get that number. So an example would be factors of 12. So our given number is 12. What are its factors? Christina?
1, 2, 3, 4, 6, 12.
Yeah. I always look for my factor buddies. So I look for the two numbers that I'm multiplying together to get to it. So I know 1 and 2. You're always going to have 1 and the number itself as its factor buddies. Then, like Christina said, we could also have 2 and 6, 3 and 4. I love what Christina did, and she put them in order. When I write down my factor buddies and I look at those numbers that I'm multiplying together to get to 12, then I take them and I put them in order. Those are all the factors of 12 in order. But always look for those factor buddies to make sure you're not missing a factor. So to find the greatest common factor of a set of numbers, we have a couple of different methods we're going to use. Okay, I'm going to teach you the different method, and then you're going to decide which one works best for you. Because all of our brains work differently. What works really well for me, and my mind automatically jumps to, might not be what your mind jumps to, and that's okay, as long as we get the same answer in the end. So the first one is the listing method. So the listing method, providing the greatest common factor is as easy as 1, 2, 3, or FCG. And we're going to learn what FCG stands for. F is for factors. Right? So we're going to list all factor pairs of each given number. Because when we're finding a common factor, we're going to have multiple numbers we're looking at. So we're going to find all the factor pairs of all the numbers that you're given. Then C is for common. We're going to circle the common factors. So the first thing you do is you write out all the factors, then you circle any factors that they have in common. And then G stands for greatest. We're going to identify the greatest common factor. So we're circling all the common factors, then we're going to see which one is the biggest out of all the common factors, that greatest number. So we list it all out. We're going to circle any they have in common, and then we're gonna see what's the greatest number that they all have in common. Okay, that's the first method. Our second method is the table method. So the table method, we're going to put 40 and 72 into a table. The reason I have this line in front of that 40 is because we're going to be using that, so make sure you have that line in front of it. So you take whatever your given numbers are and you put them on top. And you're going to ask yourself, what number can I divide out of both of those numbers? What number could I divide out of both? 8. Okay. I can divide an 8 out. So 40 divided by 8 is 5. 72 divided by 8 is 9. Can I divide something out of both the 5 and the 9? I can't. I'm stuck there. I can't go any farther. So I would take any numbers that I could divide out, I can't divide anything out of here, and I would multiply those together. I just have 8. We may have, let me do it over here. If I had 40 and 72, sometimes I don't find that greatest common factor right from the start. I look at 40 and 72 and say, I know I can divide out a 2, right? Because they're both even numbers. So I would put a 2 here. 40 divided by 2 is 20. 72 divided by 2 would be 36. Can I divide something out of 20 and 36? Claire?
2 again?
Another 2. So I'm going to divide another 2 out. 20 divided by 2 is 10. 36 divided by 2 is 18. Can I divide anything else out? David?
2.
Another 2. 10 divided by 2 is 5. 18 divided by 2 is 9. Can I divide anything else out? No. So what did I say we do? Now that we've divided everything out that we can, what am I going to do, Claire?
Multiply all the numbers.
All the numbers that I pulled out. So I have 2 times 2 times 2, and it equals 8. So we get that, say, sometimes you look at two numbers and you go, I know that greatest common factor is 8. There will be a lot of times we're given big numbers, and we're not sure what that greatest common factor is. So we look to those prime numbers that we can pull out. I can pull out a 2, I can pull out a 5, I can pull out a 3. Think about those prime factors that we can pull out. And we then multiply them together once you can't pull anything else out. So let's look at 12, 30, and 60. We're going to do the same thing, but we have to be able to pull that number out of all 3 numbers. So what do you think we could pull out of 12, 30, and 60? What's the first number, easiest number we could pull out, Fallon?
3.
We pull 3 out. We know 6 is a multiple of 3, we know 3 is a multiple of 3, we know 12 is a multiple of 3. So 12 divided by 3 is 4, 30 divided by 3 is 10, 60 divided by 3 is 20. Can I pull anything else out? Rocco? I think they're all even numbers. I can divide them by 2. 4 divided by 2 is 2, 10 divided by 2 is 5, 20 divided by 2 is 10. Now what can I pull out? Christina? I can't. There's no factors that 2 and 5 share together. Right? That's as low as I can go. I need to be able to pull from all of them. I can pull a 5 out of the 5 and the 10, but I can't pull a 5 out of the 2. So I have to be done there. So how do I find my greatest common factor? Okay, we multiply those two numbers that we took out. So 3 times 2 equals 6. So our greatest common factor is 6. Now if I had to list all the factors of 12, list all the factors of 30, then list all the factors of 60, then I'm going to circle all the common factors and then look for the greatest one. Would I still get the same answer? Yeah. Would it take me longer? Probably. Whichever one works for you, you can use. Okay, if you understand how to do the table, it's going to go a little bit faster. But if you're like, ooh, I'm not really sure, I'm not comfortable with that, but the listing, I know how to do that, I'm comfortable with that, then use that one. There is one more way that Mr. Schultz doesn't have on our book. He used to have it, and then he changed it over from doing prime factorization to doing the table method. But I want to show it to you in case you want to use prime factorization. It's making a factor tree. So let me show you how that would look. So I'm going to show you how to do that factor tree for 40 and 72. So we would start with 40 here, 72 here, and we're going to break it into, it's going to look kind of like a Christmas tree. And I'm going to think, what are my factors of 40? Who can tell me, factor buddy, what's the factor pair of 40? David?
4 and 10.
4 and 10. So I know 4 times 10 equals 40. Can I break the 4 up any smaller? Vivi? Into what? I can break it into 2 times 2. Can I break my 10 up any farther? Robbie?
5 times 2.
Yeah. I'm going to have a 2 and a 5. Now, can I break any of those numbers up smaller? Nope, can't break them up any smaller. So now I'm going to do the same thing for 72. Well, first I'm going to, my prime factorization, these are my prime numbers like we talked about in our math packet. Prime numbers, you can't break up any smaller. If I multiply 2 times 2 times 2 times 5, all of those prime numbers, I'm going to get 40 for my answer. So the prime factorization means we break that number down into all the primes that you multiply together to get that answer. So now I'm going to break up my 72 into its primes. Who can tell me a factor pair? Luke?
8 and 9.
8 times 9. Can I break my 8 up any smaller? Claire?
4 and 4.
Careful, we're multiplying. So you did 4 plus 4. 2 times 4 would be its factor pairs. It's very, very common for people to accidentally add instead of multiply. So when you use this method, you have to make sure you're putting the factors that you're multiplying together. Can I break up my 9? Hadley? 3 times 3. Can I break my 2 up any farther? Nope. That's a prime number. Can I break the 4 up any farther? Bobby?
1 times 2.
Oh. 1 times 2 is 2. What do I want to multiply my 2 by, Robbie?
2.
2. So I'm going to do 2 times 2. Can I break my 3 up any farther? Oh, if it's prime. Can I break that 3 up any farther? Nope, that's prime. So I'm just going to carry it down. See how it's kind of looking like a Christmas tree? Getting down all the way down to the primes. So now, my prime factorization for 72 is 2 times 2 times 2 times 3 times 3. So I have my prime factors for both 40 and 72. To find the greatest common factor, I look at what primes they have in common. 40 has a 2, 72 has a 2. 40 has another 2, 72 has another 2. 40 has another 2, 72 has another 2. 40 has a 5, does 72 have a 5? Nope, they don't share it, so I can't write it. Does 40 have any 3s? Nope, they don't share it, so I can't write it. So, to find the greatest common factor, I multiply the primes that they have in common, and I get the same answer. A lot of people find the table method easier to understand and less mistakes that you make. When I was your age, I learned how to do the prime factorization trees. So that's where my mind jumps to. It is another way of doing it. Your parents might know this way. You don't have to use it if it doesn't resonate with you, right? If you're not like, oh, I get that, I want to use it, don't use it. Use the factor tree, or the table, if that one works for you. List them, if that one works for you. The more methods we can learn, the better chance we're going to find the one that works for us. All right. Numbers are relatively prime. It sounds pretty cool if you say it in a British accent. I'm not good with accents, but Mr. Schultz is. If their only common factor is 1, if the only number that they share in common is 1, we call them relatively prime. They are not prime numbers themselves, but are prime when compared to each other. 8 and 15 would be an example. Can we break 8 down into factor pairs? Yeah, 2 and 4, 1 and 8. Can we break 15 down? So 8 would be 1, 2, 4, and 8 are its factors. 15 would be 1, 3, 5, and 15. The only factors they share in common are 1. So we call them relatively prime because they only share 1 as a factor. They don't share any other number. So that's just something we need to keep in mind, that there might be relatively prime numbers that we have to find the greatest common factor to. But you have to always be checking what are all the factors of the number. Make sense? Does every number have 1 as one of its factors?
Yeah.
So there'll never be a time that you'll say, oh, these numbers don't share any common factor. They will always have at least 1 as a common factor. A lot of times they'll have a greater number. Sometimes it's just 1. So, on our second page, our directions say find the GCF. What does GCF mean? Christina? Greatest common factor. Find the GCF, that greatest common factor of the set of numbers. You may use any of the methods. You can list, you can do the table, you can do prime factorization. Any of those methods would work. You only have to do one way. It's possible that the numbers might be relatively prime. You must show your work. I should be able to look at your assignment and say, oh, you did the listing method. Oh, you did the table method. Oh, you did the prime factorization. You have to show your work. You cannot just look at it and say, oh, I know 40 and 72, the greatest common factor is 8. I'm going to put in 8 and be done. When we do our homework, we always, always, always show our work. Okay? When it comes time for the test, we're going to show our work. So we can see, I will know if you're going wrong, where you're going wrong. I need to make certain that you understand what you're doing. On our homework, we have to show our work because if you get a wrong answer, we want to learn from it. So we need to be able to look back at our work to see where we went wrong. But you get to pick which method. Let's do the first one first together. 24 and 84. Which method should I use? You want to do the table? Okay. So I'll do the table. 24 and 84. What number can I pull out of 24 and 84? Tyler? 2. They're both even numbers, I know I can pull a 2 out. 24 divided by 2 is 12. 84 divided by 2 is 42. Can I pull any number out of 12 and 42? Claire?
2.
Another 2, they're both even numbers again. 12 divided by 2 is 6. 42 divided by 2 is 21. Can I pull any number out of 6 and 21? I believe 3. 6 divided by 3 is 2. 21 divided by 3 is 7. Can I pull any number out of 2 and 7? No. So now remember, I'm going to look at what I pulled out and I'm going to multiply it together. 2 times 2 times 3. So 2 times 2 is 4. 4 times 3 is 12. My greatest common factor is 12. I'm going to circle it so it doesn't get lost in my work. So I'm going to circle that answer so it's easy to find. So that's showing my work and it's showing the answer. Any questions on that? We do have a third page. So that first page isn't homework. That first page was just the lesson. This third page is going to be word problems. Yeah, you're going to have to do the second page. You're going to work on it on your own. Let's look at this third page. Let's look at how we do the word problems. Friends, it's the same thing. They're just putting a bunch of words in there. We're going to do the same math. You are creating prize bags to give to guests at your birthday party. You have 18 kazoos, 45 fake tattoos, and 36 stickers. So those are our key numbers. 18, 45, and 36. Oh, the stickers have famous mathematicians on them. What is the greatest number of identical prize bags you can make using them all? Greatest number? What's the greatest common factor between those three numbers? Greatest common factor. So we could say 18, 45, and 36. If I use that table method, what am I going to divide out, Robbie?
9.
Give me a smaller one.
3.
3. Because Robbie was jumping ahead saying, I know the answer. If you don't know what the greatest common factor is, pull out smaller numbers. 18 divided by 3 is 6. 45 divided by 3 is 15. 36 divided by 3 is 12. I started to write the wrong number and I caught myself. I had to stop and think. 12. What can I divide out of 6, 15, and 12? Hadley?
3.
Another 3. 6 divided by 3 is 2. 15 divided by 3 is 5. 12 divided by 3 is 4. Can't pull anything more out of all three of those numbers. So if I multiply that 3 times 3, I get 9 is my greatest common factor. So 9 bags. That's how many identical bags there are. There is a second question. How many fake tattoos will be in each bag? Well, there are 45 fake tattoos being divided up into 9 bags. So how many of the tattoos would go evenly into those 9 bags? Beckett?
5.
How did you figure that out, Beckett?
Because 45 divided by 9 is
45 divided by our 9 is 5 tattoos in each bag. Make sure you are answering all parts to your question. This question had 2 questions inside of it. You need 2 answers. 9 identical bags, 5 tattoos in each bag. Make sense? Okay. You are going to work on that second page, finishing up, finding that, just straight up finding the greatest common factor. Then when we come to the word problems, we're going to know, hey, this is the greatest common factor objective. all these word problems have to do with greatest common factors. But I'm gonna make sure I'm answering the correct questions. It might not just be asking what that greatest common factor is, there might be asking something else from that. So make sure you always go back, is this answering the question? Any questions on today's assignment? David?
Do we do the time for review at the bottom of page 3?
Time for review will be on a lot of our problems now that we've done several objectives. That review, we forget what we did last week. In 2 weeks, we're gonna forget what we did at the beginning of this unit. So there will be review questions. If we have questions on the review questions, where can we look for how to do them? David?
You look back in your binder.
Look back in your binder to those objective pages. If there's a question on rational numbers, go back to the page that had the definition for rational numbers. Oh, that's right, that's how I do that. We review these things throughout the chapter, throughout the unit, so that way we're not forgetting what we did in the beginning. Okay? So yes, you have to do the review questions at the bottom of the page. Any other questions? All right, if you are watching this at home, I hope you are well. I hope to see you soon. Don't forget to like and subscribe. Have a wonderful day.